Okay, so welcome to my talk. Today I want to introduce you Wake framework, which is framework for Solidity development and testing and so on, and it could potentially enhance your tooling stack. My name is Jan, and I am tech lead at Ackee Blockchain. We are doing mostly blockchain security audits, but also apart from that, we are developing open source tools, where Wake is one example of that. Also, we are onboarding some new developers to blockchain, where we are doing, for example, some online courses, but we are also teaching on Czech Technical University at Prague.
Please read out.
Okay. We are currently, I think, more than 3 years in the space, and we already worked with protocols such as 1inch, Lido, and Safe, and that will be the self-introduction, and we can jump to the tooling part. So, I will have a question on you. How much people here is testing their code? No one. Oh, that's a shame. Okay, so I hope that there will be at least someone. Then who is fuzzing his code? So that's less popular than testing, but more powerful potentially. And another one obscure activity is static analysis. Today I will present you a tool which combines all these things together, and it's called Wake. So the first part is the static analysis framework, which consists of vulnerability detectors and code printers. The second part is the testing part, where I have to say at first that Wake is Python Solidity testing framework, so everything there is written in Python. So we have, for example, available Python debugger, and you can obviously write a unit and integration tests in it. But also it has its own fuzzing engine, so you can fuzz with that, and it also supports cross-chain testing, fork testing, and a lot of other things. I think there's already covered all the features what you need to properly test your smart contracts. And the last important thing is it has also its own language server, which enables us to build the VS Code extension on top of it. Okay, so we will start with the static analysis part, where we have CLI, but also the graphical interface for the detectors and printers, which is provided by the VS Code. But you can also use, for example, detectors in your GitHub pipelines, where it is very convenient because developers just push their code to the repository, and it gets automatically checked against vulnerabilities. And also there is a API to write your custom detectors, which can be pretty handy because you can create some detectors which will be just a project specific, and you don't need to have them generalized for all the projects. Okay, so this is example of some trigger detection, where this specific problem lies in that using for directive is unused in the contract, which means when we implemented this detector, it turns out it is very popular because devs just specifies safe ERC using for directive at the top of the contract, but then forgets to actually use it. And it can make a confusion that those transfers in the contract are safe, but they are actually not. So this is triggered when the directive is unused. So it is more for code quality, because this is redundant, but it can also lead to some more serious issues. Another interesting example is the ERC4337 detector, which is for account abstraction projects, where it can detect if you use some forbidden opcodes or you are using restricted storage access. Then when this detector is triggered, then your project, for account abstraction will not work correctly. So this is like very convenient to use because checking it manually can be more exhaustive. So actually, why we decided to write our own static analysis framework was that we want to have precise detectors, and because devs are then more motivated to use the static analysis when there is not so much false positives. So this is just an example of one chosen detector where we took 50 random contracts and tried to compare it with the same detector from Slither, and we got like a pretty cool F1 score, which basically means how much you are satisfied with the detection. This is example how such a detector can look like. It can be like hundreds lines of code, but it can be also something like 7, 8, where this specific detector on these few lines is doing the thing that it will detect all the functions in your code that contains unsafe string, and they don't have only owner modifier. So if you have, for example, in your project you are using heavily some functions that where you are using that they are unsafe, you want to be sure that you will also always include the only owner modifier. Then you can just write this detector for a few lines and it will check it for you. Then we have their printers, which are very similar to detectors, but they are about extracting some useful data from the code base, where it can be, for example, translated to graphs, or it can show, for example, storage layout or some statistics of the code. It has also language server integration, so you can use it very nicely in your VS Code. I will show it later. And it has also API for development of custom printers, which is also pretty handy. This is example of one of the printers, which prints the storage layout of some specific contract, where if you are using upgradable contracts and doing some upgrades to new versions, then it can be pretty handy to use this one, because you will see if there are no storage clashes very easily. And this is example how the printer can look like. So it is very similar. How to write detectors, how to write printers, almost the same, but it's more about the intention. With detectors you want to detect some issues, and with printers you want to just get something useful from the code. You can write printer for some one-time job, just to print some information what you need, but you can create also something like more generalized, which you will be using like every day. This one is like my favorite one, where you print all public and external functions in the contract, but also in the whole inheritance chain. So I will show you later how this is like useful. Okay, so let's move to the testing part. So this is example of a simple test written in Wake, where we have a function which tests some ERC20 token, and essentially what we are doing is that we do just a transfer of USDT. So it is very compact, and in this special case we are doing fork testing, which can be seen in the chain.connect decorator about the function declaration, and where we are connecting to some RPC endpoint which is on localhost, and with this we just get the USDT from the mainnet and use it for transfer. So this is very useful if your protocol interacts somehow with some tokens. Then USDT is a pretty unusual token in terms of API interface, and you can check if you have everything implemented correctly, and it will also work for USDT. If you would like to turn this test into cross-chain, you will just add more chain.connect decorators. So you can have, for example, two chains which are just deployed locally from scratch, and you can have then, for example, Arbitrum that is forked. Okay, so when something went wrong in the test, then it is pretty handy to use call traces. So you won't see only the revert message error, but you will see also the whole call trace of the execution of the transaction, and there you can more easily identify what you implemented wrong, or if the problem is in your test file, or if it is in the Solidity part. And what is even more better is that you can use debugger, and in that case, when your test case fails, then a debugger is attached to it. You can, for example, get the call trace, but you can also explore the state of the chain, get all the, for example, balances, state variables of some important contracts, and so on. So then we are getting to fuzz testing, where we are doing something, well, what we call manually guided fuzz testing. It is approach which is very similar to Foundry and different from how it is doing Echidna. And we are doing it in a way that we are specifying invariants and flows, where flows are basically some scenarios, what you want to do with your protocol. It can be, for example, we will have a flow for a transfer, then that flow will take random address A, random amount X, random address B, and it will do transfer from A to B with the amount of X. So this will be some scenario for the protocol, and this will be executed multiple times, and we want to check if the transfer happened correctly. And this can be done with a stateless or stateful invariants, where stateless invariants are basically just assertions, as we've seen in the test file. These asserts, these are basically the stateless invariants, where we check just for the operation, but we are not bringing that context to another flows. But we can do a stateful invariance, which is shown on the code example, where we can track the balances of the accounts and check the invariant after each flow if it holds. When we are doing something like that, then we are very close to something which is called differential fuzz testing, where we are creating a model of the protocol in Python. So we have deployed some Solidity contracts with which we are interacting, but we have also the whole model in Python, where it is especially useful for some DeFi protocols such as was IPO, where we had a specific formula from white paper which we implemented in Python, and which is the whole code snippet of that math equation. And with that, we could run several flows over the whole protocol and check if the formula is always correct with very big precision. And this helps us to discover very special issues which couldn't be found with a manual review. So when you have some map-heavy project, then you can discover with this some rounding issues and things like that. So this one is very handy. Okay, so now a few moments of fame. So it was already useful for us. There are some real issues what we discovered with the framework, where the first 3 rows are from static analysis, and then the rest is with the fuzzing. The issues found with static analysis are always very satisfying, because on the day 1 of audit you actually get some really nice issue which you can share with the client. So it's always nice. It's something what you a program will do a job for you. And then we had one guy on the university which spent some time by rewriting tests of Uniswap v3 core from Hardhat to other Python frameworks, and he did some measurement. If you will be more interested in it, then I can recommend to check the link in the bottom of the slide on GitHub, how it was measured. But Wake went from that like with a pretty good performance in comparison with others. So, and this is just a high-level slide which compares like the current frameworks which are like mostly used. And here I just have to say that I already, for example, seen projects where they were written in Hardhat. They were using unit tests in Hardhat. They were using Slitter for static analysis, and they were using Foundry for fuzzing. So instead of 3 frameworks, you could, for example, use just one. So that's also the reason why we are building this. And yeah, so this was the Wake, the CLI tool. You can download it with Python Package Manager and use it independently on this. And this VS Code extension is also completely independent, but when you are using the both things together, it's more fun. So the extension in VS Code provides you like a graphical interface for the detectors. So it is like a more convenient. You have vulnerability highlighting directly in the code. So when you are developing some new code, you can actually see in the real time that you are creating some criticals. So it can be pretty exciting. And this is the printer, what we mentioned about printing the public and external functions. So this is like, it seems very trivial, but it is a very nice thing. When you are just looking at some contract, and that contract can have, for example, 12 contracts in the inheritance chain, and these contracts can have some public and external functions. But when you are, as a developer, writing the contract with the whole inheritance chain that is somewhere hidden in node modules and other external folders, you just can miss that there are some functions that are available. And with this printer, you just click at the bottom, and you can see that in the ownable.sol there is one function that can be called, but it's not visible in the contract. So, but you will see it easily here. So these printers, alongside the extension, are doing like the code navigation extremely smooth, and it can help you discover like a very easy bugs. Also, when you are a fan of test coverage, then it can display the test coverage directly in VS Code, also live. And the latest thing what we added is a Remix-like experience. Do you know Remix? Yeah, I think it's pretty popular. I also like it, and my dream was to bring it to VS Code. So, so finally, it's like I think 2 months from release, we get to it. And now you can just open any download any project from GitHub, open it in your VS Code, and interact with it as it will be a remix. So, for example, here I am choosing from the code base to deploy ERC20 token, where I will just fill the string and symbol and deploy it, where in the transaction viewer I will see if it was successfully deployed. I can check the transaction receipt, and then I can interact with it. So I can increase some allowance, I can transfer it, and so on, and all these things without writing any code, just by clicking. So it's very nice. And yeah, so this was the extension. We talked about Wake, the extension on top of the Wake. And last thing what I have, what I want to disclose here in Thailand, that we are currently working on rewriting the core part of the framework to Rust. So it will be also blazingly fast soon. So we currently measured something like approximately 10x speed up, but on some tasks it is even greater. So I know that Python is unpopular language for someone because Rust is trending now more. So it was inevitable for us to also implement it to get rid of the Python, which is slower in some things, and implement it by Rust. So if you will be also interested in some learning resources. Then for the tests, I can recommend Awesome Bake Test repository, and for detectors to check some existing one. And that's it. That's the talk. So thank you.